objective. So we're going to talk about the multiplication property of equality. And it says something like this: multiplying each side of an equation by the same, and in parentheses I want you to put non-zero, can't be zero, number produces equivalent equations. Highlight non-zero for me in your notes, because it's going to be very important when we talk about division. And where there is multiplication, there is division. So that's next. Division property of equality. And that says dividing. Each side of an equation by the same, very important, non-zero. Can you divide by zero? No. Produces equivalent equations. Here, non-zero is very important. You can never, ever, 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 never, never, ever, ever divide by zero. Uh-huh. What do you believe? If you add them, yes. Can't argue with the facts of math, unfortunately. I've tried, believe me. Yeah. Okay, we've got 15 more minutes, so we're going to keep going. While this is fresh in our mind, turn over to 22, right across the street. Oh, okay, hurry up. Let me pause. Y'all go ahead. I don't know, I've never come to the end of it yet. Guess I ran out of disk space on the computer. Okay, we'll just put this on 23. All right, here's some examples. We're going to look at examples of both multiplication and division properties of equality. Okay, multiplication first. The whole goal of solving equations is what? To find the x or the a or whatever variable is there. And we do that by getting it by itself. If we get it by itself on one side and everything else on the other side, that's solving it. Okay, so here's an example of we're going to use the multiplication property. So I have to start out with division in order to undo it with multiplication. So don't fear the fraction. My equation is x divided by 4 equals 3. So I'm going to put my fence. It divides both sides. How do I undo x divided by 4? Multiply it by 4. So now I'm just going to rewrite it. X divided by 4 times 4. And if I multiply this side by 4, I need to multiply this side by 4. You've got to do it to both sides. Now, what would this look like if I multiplied it out? It would be like 4x over 4 and equals 12. And how would I get rid of those 4s? Cancel each other out, right? Because 4 over 4 is what? 1. And 1 times x is, and I will just be real honest with you, there's not a mathematician alive that's going to write a 1 in front of that x. Because how many x's do you see? 1. Now, when it comes to 2x, we have to write 2x. But realize that this 1, we just don't write it because we're too lazy to do that. Here's our x equals 12. Okay? So isn't 12 divided by 4 3? We're all good. So we undid this division with this multiplication. So somehow label that. Used multiplication, and you can abbreviate MULTIP to undo division. Right there. And then whatever we did to one side, we had to do to the other side. So there it is on that side too. Nothing hard about that, is there? All right, let's look at using division. Yeah, very similar. Here's my equation to start with. 3 times x equals 12. For now, let's draw our fence. I need that x to be by itself. So I've got to get rid of that 3, right? It's multiplied. How do I get rid of that? What's the opposite? Division. I'm just going to rewrite it here just for neatness sake. So now I have 3x divided by 3. Well, 3 over 3 is 1, right? So I can cancel that out. That leaves me with my x. What is 12 divided by 3? 4. So x is 4. Is it 3 times 4, 12? We did it. There's my answer here. It's not. Now, what we'll be doing, and the reason why I make you go through these steps, even though you can see the answer on your own, is that by the end of the week, we're going to be doing problems where we add and subtract, and then we multiply and divide, called two-step equations. Right now, we're just doing one-steppers. Okay, there's one more definition I want us to write down. Are y'all good with that? 3x over 3.
Little note things to decide.
Oh, you can. Yeah, here we used division To undo, this is our undo button. To undo multiplication. Okay, right there. And then what we did to this side, we also did to the other side, so I'll circle that. Always check for those things. Make sure you've done it to both sides.
Oh,
That's all right. You're probably close.
I meant
No.
to- I meant to circle
Not even
this.
close. Okay. Okay, now go back to, when you've gotten that down, flip back over to 23. There's this perfect amount of room here to write one more definition. Yeah, let's get it today so we can talk about it tomorrow. Huh? No. We don't need that much room. Reciprocal. What's a reciprocal?
Reciprocal means like when you're doing keep it, change it, reciprocal. The opposite of
Flip it. That's the flip it. It's the flip it part of keep it, change it, flip it. Okay, this is what a reciprocal is. If you have 3/5, what's the reciprocal? 5/3. So y'all know that. You flip the numerator and the denominator. What's the reciprocal of 2?
-2.
No. Okay, how do you write 2 as a fraction? 2 over 1? So what's the reciprocal? 1/2. That was a trick question, sorry.
Wait.
2 is really 2 over 1. So when you flip it, it's 1 over 2. So it's a half.
That'd be with any number.
Yeah, just flip it. Any whole number. You write, if you want to write any whole number as a fraction, you're going to write it over 1. Okay? Now, to get the reciprocal, you just flip it. Okay, so here's the property. To eliminate a fraction in front of the x, multiply by its reciprocal. Yes. Now, when you're done writing that, we're done for the day. We'll pick up here tomorrow. Thank you.